So hi everybody, this is Frank Cohen. I'm the CTO and the founder at Appvance, and for the next 40 or 50 minutes or so, we're going to be talking about using Jenkins for continuous load testing and mobile test automation. There's something like 380 slides here, so obviously a lot of content. I'm just joking about 380, of course. The copies of the slides will be made available on slideshare.net immediately after the webinar. So we have basically 5 topics to talk about. Kind of, how the Agile methodology came about, and the linkage from Agile methodology to the tools and processes to do automatic build, deployment, and test automation. Then we'll talk about kind of a continuous integration strategy that hopefully will work well for you and your organization. And then we'll talk about how you move from kind of continuous integration to continuous testing, and then how to repurpose those tests that you've built, maybe as functional tests, to be performance tests. And then hopefully along the way, you'll get enough information that I'll be able to urge you to become kind of an architect for your group. As Mira indicated, if you have questions, just type them into the questions box within the GoToWebinar window. We'll see them immediately, and we've got several points within the presentation picked out to answer your questions. So, what is the Agile software development methodology? Well, it came about around 10 years ago when a group of software engineers who were working using a process called waterfall really began to burn out, and they said there's got to be a better way of developing software. And some of the hallmarks for kind of Agile software development were, hey, let the engineers, let the developers themselves take responsibility over the improvements that need to be made to a product or to a service, and then do it in a very iterative fashion. And so they got together as a group and published this thing called the Manifesto for Agile Software Development. And by itself, it's pretty good to read. It's just this one page that you see up here on the screen, but it's quite compelling. So almost immediately after they published that manifesto, they began work on kind of defining what an Agile process would be. And that process was around doing a whole bunch of small iterations to improve a piece of software or a service, instead of doing these giant, giant projects where you have like 9 months of development leading to one release. Instead, they believe, hey, maybe we could do these things called Agile sprints that would take an average from 7 to 14 days. So you can imagine what you could do in 7 to 14 days. Probably a bunch of small iterations, and maybe if you package those up, you could then work towards a release. So here's how it works. To define a 7-day sprint, one defines a plan, and that plan, normally the engineers and the testers and the business managers would get together and figure out what the backlog of changes and improvements are needed, and which are the highest in terms of priority. So, for example, here I've listed 4 of them out. So the application does not run on iOS, the iPhone operating system. They're rendering problems. The user experience fails when 45 users are on it. These are just typical of the items that might be in a backlog. I've even seen in some sprint planning meetings that they'll print these individual backlog items onto like Post-it notes and put them up on a wall, and then it's up to the developer to like literally take the Post-it note off of the wall and put it in his corner of the wall, saying that he'll be responsible for doing it. And I shouldn't say he; it could be he or her. So what happens is then you've defined a backlog of changes. You go into this 7-day period called a sprint, and then every day you have basically working standing meetings. Oftentimes these are called Scrum meetings. And where you're going is at the end of that 7th day is to do a sprint review where you're basically going to either accept the changes that have been made or you're going to pass them back into the backlog. So when you get to acceptance, acceptance is proven by a series of tests. So the matching of the Agile method to testing was there from the start. So, for example, acceptance might mean that you have a certain number of unit tests that are going to pass, certain number of functional tests, maybe usability tests for the user experience, certainly performance tests, stress tests, and then making sure that the production monitoring for the app improvements are going to be there. And all of that leads you then to a release. All of the things that don't pass acceptance then go back into the backlog and then are dealt with in the next 7-day sprint. So why would you do Agile without continuous integration? Well, I would put it to you that continuous integration is kind of a natural outcome of the Agile Manifesto. I mean, it basically says that as you're doing these small iterations, that the unit tests that you're going to write, that the agreements that you're going to have between the engineers, all of those will manifest themselves in a set of tests that could be run automatically. So that I would ask myself the question, like, why do continuous integration? Well, I've listed out these 6 items which I think are positive for continuous integration. So first, it's free. I mean, Jenkins, for example, is open source and it's entirely free. The source code is available to you. There's a hugely healthy community backing it up. There's always improvements to it, and it's consequently pretty easy to set it up. The other reason to do continuous integration is that you might have test suites themselves that run and take a long time to operate. And what you'll be seeing in today's webinar is me showing this system for building unit tests of iOS and Android apps called Appium. Well, running those tests can take a seriously long amount of time. I mean, like one unit test could take 30 minutes to run. So if you have a continuous integration environment like Jenkins, Jenkins automatically has kind of a master-slave architecture to it. So it can run multiple test suites concurrently. So if 8 hours of time overnight is no longer enough time to run a test suite, you could easily have Jenkins parcel these up into concurrently running unit tests. The other reason to do continuous integration is because if you're working on an app that is really high risk to the business, like Appvance has done lots of the testing for PepsiCo when they launch an app that is in support of one of their marketing campaigns. So if you've got a high-risk app launch, continuous integration will be the first time that the business managers on the app will be able to see what the business risks are around launching the app. The other thing I find is that as new people come into the project, like Appvance just hired a new engineer, and he kept asking questions like, well, how do I build this or that part of the Appvance PerformanceCloud product? It was pretty easy to just point him back to Jenkins, because Jenkins itself, in one of the project definitions, had all of the commands that engineer would need to use to actually do a build or deploy or test. So continuous integration becomes kind of the place of record for any of the project work that is going on amongst your team. It's also very easy, once you've adopted continuous integration, to go from functional to performance testing. You know, in the past, I've seen many people say, well, functional testing or performance testing, you choose one. With continuous integration, I'll show you how it's easy to go from one to the other. And you know, it does keep you productive when long projects are there doing build, deploy, and test. You know, who wants to watch that scroll by on the screen when you could have an automation system take care of build, deploy, and test for you? But there are some places where continuous integration probably isn't for you. So if you work in a really small shop, like if it's just yourself and maybe 1 or 2 other people, it could be that you just don't have the time it takes to maintain a continuous integration platform. Secondly, if the stakeholders aren't able to participate as the test automation or the continuous integration platform is running, then that might not be the right strategy for you either. The stakeholders might be like the DevOps managers who would know how to bring a database back up and running after a continuous integration deploy failed. The stakeholders could be the business manager who notices that 3 out of 4 of the most recent builds have failed, but doesn't pay any attention to it. So the other thing is that Jenkins, while it is mostly automatic, it really does need somebody to manage the projects on Jenkins. And so if you don't have somebody that can be designated for that, then you might want to avoid it and just take a manual approach. And lastly, if you're working on kind of a one-shot project, right? Project where, hey, you're going to build it once, you're going to launch it, and then you're going to forget about it. Yeah, Jenkins probably overkill for what you need. Okay, so the thing about Jenkins is that while it originally was set up just to do kind of automatic or continuous build of a platform, it really has grown up much past that. And I would call it now kind of continuous DevOps. DevOps is a movement that got started around the time that Agile got started, and it's analogous to Agile, but DevOps really applies to like the operations managers, the network managers, the kind of operations folks. And so what you wind up with continuous DevOps is this really great ability to do automation across the board. So continuous integration gives you a great way of automating a build of an app based on a new source code check-in. Continuous deployment then would automatically take that built app and then deploy it to your production or pre-production environment. And continuous testing itself would be able to do regression testing automatically on one of those software commits and then repurpose any of those functional or unit tests to be performance tests or load tests. So what you wind up with is continuous integration becomes kind of the center point for an overall system that has a test capability, the runtime for the actual app, the monitoring capability, a ticket management system, and a source code repository.
Frank, we do have a couple of questions.
So how do you get...
Sorry
to interrupt.
Mary. We have a couple of questions. The first question is, who are the stakeholders? And the second one is, do I need to follow Agile methodology to use Jenkins?
Well, the stakeholders would be all of the people that would sit around the table typically when you're doing a performance test. So like when you're running a performance test, it might be that your performance test takes down the app. That would have an immediate impact on the operations manager, on the database administrator, on the person running your web servers, on the people running your mobile interfaces, on the developers certainly, maybe on the architect. Those are the stakeholders that I was mentioning. And then, Mira, could you repeat the second question?
Certainly.
I think you're on mute.
I got it. Certainly, the next one is, do I need to follow Agile methodology to use Jenkins?
So Jenkins by itself is useful for automation. However, you don't have to be working in an Agile shop to make use and benefit from Jenkins. It could be that all you need is really a wonderfully powerful make utility, and that's what Jenkins turns into. Any other questions?
Not at this time.
Okay, so let's talk about how you get Jenkins. You have a bunch of different options. CloudBees, for example, is a software as a service provider where you buy a subscription to the CloudBees service and they fully manage the Jenkins installation. I'm going to show how that works on the next slide. But you could also self-manage your Jenkins installation just by running it on a cloud environment like Amazon Web Services or IBM SoftLayer or any of the other cloud providers. They will have pre-built images that have the Jenkins system already up and running. You just fire up one of their cloud instances, and then you add your own project to that instance. If you want to run Jenkins internally, it's very easy to download Jenkins from the Jenkins website and then be able to do an install and to operate it. And then, what we recommend is after your Jenkins installation is set up, then plug in testing as a service platform, and there are a couple of different providers, including Appvance, to do that. Okay, so let's look at a typical Jenkins configuration using the CloudBees environment, and I've got that on this slide here. So here I am logging into the CloudBees environment, and you can see I have a number of different projects that are up and running, and this is a typical Jenkins setup where I've got a project configured. The project configuration is all done through a web interface, so it's really pretty easy to set it up. It supports all of the major repositories, so if I'm using a CVS or Git or Subversion, I've got immediate support for that. And then if this was a Java-based project, then I could very easily just execute an Ant-based task from this Jenkins setup. There are lots of plugins that are available to Jenkins. Appvance produces a plugin so that if you wanted to have Jenkins integrated with the Appvance PerformanceCloud, then that's fully supported. So this just gives you an idea of what it looks like when you configure a project. And then actually executing the project is also through the web interface. So Jenkins shows you the progress of the build of your app. If you've integrated it with a test environment, then it also shows you the test results as you can see here. So it's all very web-based. It's all very quick to set up and configure. And I find that the most amount of time that it takes for me to set this up would be like administering the user accounts and setting up the like where the machines will be that Jenkins actually does the builds. Okay, so now let's talk a little bit about what it takes to move from continuous integration to continuous DevOps. And what I would put it to you is it's really around the goals that your organization sets up for themselves, for yourself, and those pretty much come around that acceptance phase of the Agile method. So, for example, if you're needing to do unit testing or functional testing or usability testing to accept the changes that you've made during a sprint review, then those really boil down into the three following areas. And what I find is that there isn't like an academy or like a graduate program at university that could teach you this stuff. And so I find that there's a huge amount of a difference when you talk from one tester to another about like what the real goals are for their testing. So I would put it to you that the testing goals are these three. Functional testing defines the end user experience success. So the idea of functional testing is that you're not trying to test like an individual unit, but you're really trying to test to see is the end user able to successfully use the app. Now, functional testing might be broken down into individual units. For example, you could be doing functional testing to make sure a particular browser is compatible with the app. You could be testing to make sure that the user experience is giving you a good latency so that the end user doesn't get bored or despondent while the app is running slowly for them. It could be that you're just wanting to make sure that the app itself has passed through the configuration and integration problems that might exist when the app was being deployed. So that's functional testing. Performance testing identifies the business risk to the launch of the app. Basically it answers for the business manager the question of how many people is the app ready to serve at any given time. In the case of Doritos, who has, Frito-Lay, who has this product, Doritos, it's basically crisps or chips here in the States, they wanted to make sure that the app would be able to serve 50,000 typical user transactions every 10 minutes. And provided it met that metric, then that meant their business risk to launch was low and that they could launch. If they couldn't achieve that level, then the business managers had inputs to their business risk analysis and they could decide whether it was ready to launch or not. And then there's the third category of testing I call stress testing. So this is really identifying what the end user experience looks like as the app fails. So one of the banking customers at Appvance had an app that they deliver to their high net worth individuals. And the downside is that they didn't really test at stress levels. What they found is that when the number of users got above a certain level, the app was stressed out and it started showing other users' banking details. So that's a catastrophic mistake, but it's only one that the bank would know if they accomplished stress testing. Now the issue here is that a lot of testers will say, hey, I'm really good at one but not the other two. So they might be really good at performance testing but not at functional testing. Well, this kind of testing measures business risk, and it's really important for you to know that there are all sorts of tools and techniques out there to help you do all three: functional testing, performance testing, and stress testing. So let's talk a little bit about how that would work for you. The first thing is to realize that all the tools aren't made equally, and they weren't made at the same time. So if you look at how Ajax apps are put together today, what you'll find is that there's kind of a new architecture that most developers are using. This is called serverless architecture. It means that you initially open your browser and point to a URL, and the page that loads is going to have all sorts of JavaScript programming built into that page. So most of the time, that page won't have to refer back to the server that originally served up that page. Instead, all of that JavaScript on the page is going to talk to a whole bunch of different back-end services, and those services might not even be in your own data center. It could be coming from anywhere else. So those pages have statefulness, they have workflow, and they have communication, which means that if you're trying to test using a protocol level test like JMeter or LoadRunner, you're really going to find almost immediately that those kind of tests just won't give you the results that will be meaningful. What you also need to know is that the developers of those pages are going to really need real-time analytics and kind of an immediate fix, and they're going to need both of those at the same time. So when you're looking for test tools and techniques, make sure that whatever effort that you put into that test tool is going to deliver something in real time to the developers, because they are one of the stakeholders that's going to have the best impact at improving the app. And then there's this issue of beginning to end testing. You know, a lot of effort in the testing space over the last like 15 or 20 years went into protocol level testing. That is, these tools would look at how the app talked to the backend system and then mimicked those protocols. But since these Ajax pages, these mobile apps have statefulness and workflow and communication in them, the protocol level testing really has reached its limit for what you can do. And I've seen these terribly long LoadRunner scripts that typically are like 600 or 800 lines long, just trying to emulate what the protocols are doing to support the test of an app. Whereas there's a much better way of going, and I call it beginning to end testing. The idea here is that you fire up the real browser, and the real browser fires up the real app or the real page. And the app or page that's running really is going to talk to the backend system. It's going to talk over the protocols that are native to that app, but you're testing from beginning to end of the app, meaning you're driving the whole app itself, not just the protocols. So the other thing is, in terms of testing strategy, is that whatever you implement is going to need to scale up to your team's efforts. So at Best Buy, for example, they have something like 3,000 testers, 3,000 engineers and about 300 testers. To be able to achieve testing at that level requires you to make a pretty good investment into test management. So if you look at continuous integration platforms like Jenkins, then you should also look and see which which test management platforms are complementary. For example, Rally is complementary with Jenkins. IBM Rational Quality Manager is complementary. There's a bunch of them that are out there. And then lastly, make sure that whatever you choose is going to be cost effective. In an Agile setting, Agile expects that a tester is going to be paired with a developer, and so the tester needs a license to the test tool, and the developer needs a license to the test tool. And a lot of legacy test platforms out there just price themselves out of being applicable to Agile just because they're too expensive to provide licenses to everyone. Okay, so
Frank,
how do you get app testing? Well, app testing tends to break down. Oh,
sorry,
go ahead, Mary.
Frank,
Thank you.
we do have a couple of questions. Is Jenkins the only choice for CI? What about the others, is the first question.
Oh, there are lots of continuous integration platforms out there. I think I like Jenkins best because of its open source roots, but there are plenty of others. Like I could point you to Bamboo, to Cruise Control. If you do a search for continuous integration, you'll wind up with a big selection to choose from. Jenkins seems to be the leader and has the most healthy open source community that I've seen.
And our second question is, what is the difference between beginning to end and end-to-end testing?
Well, beginning to end testing fires up the real app. If it's an Ajax app, then it fires up a browser. If it's a mobile app, then it fires up the app in a mobile environment. End-to-end testing is something that I think HP kind of made popular when LoadRunner first came out about 15 years ago. The idea there is that they would watch the app talk to the backend system over its native protocols. Like it would intercept the HTTP protocols. And that worked fine when, before the cloud showed up with really inexpensive machines to be test injectors. But now that we've got Ajax in the wild and we've got mobile apps in the wild, it's really necessary to do beginning to end testing where you fire up the real app and drive it as the real end user. Any other questions?
No, that's all for now.
Okay, so how do I get app testing? Well, they kind of have two areas to look at. One would be testing of Ajax apps, and the second would be testing of mobile apps. For testing an Ajax app, you have a bunch of different solutions. I'd recommend you take a look at Sahi or Selenium or WebDriver. These are popular open source projects that can do beginning to end testing, and they're really good at building functional tests. You could, of course, write your own library of unit tests in a high-level language like Java or Ruby or Groovy, PHP, or any of the other high-level languages. It's going to be more difficult to write a unit test and to get it to work. However, with a unit test written in a high-level language like Java, you could write it as a set of objects, and that object library will be much easier to maintain over the course of its lifetime than if you were to write in Sahi or Selenium or WebDriver. There are other tools out there like JMeter, which got started in the Apache group to test the Apache web server. JMeter does great at protocol level testing, but it doesn't work in an Ajax environment. So I'm sure that you have information about your own favorite Ajax app. If you do, just type that into the questions box in the GoToWebinar window, and we'd be happy to know about that, and I could even read that for you. The second category of testing then would be in mobile apps, and for that, we'd highly recommend Appium. Appium is an open source platform for building functional tests of iOS and Android apps. It informally has the blessing of Apple for iOS, and Android being a Java-based platform, Appium runs great. It basically gives you the equivalent of the WebDriver APIs, but in a way that work specifically for iOS and Android apps. And I'm going to show you a demonstration of that coming up. You could also write unit tests of the SOAP and REST calls that might be used by a mobile app to talk to a back-end service. That would basically be protocol level testing at the REST or SOAP level. And you can use popular tools like SOAP UI, the HTTP archive, or HAR for short, and JMeter. Those would be good solutions. But in that case, the unit testing would be only testing at a protocol level, and you wouldn't be able to understand whether the user experience has been varied or isn't performing well, or if the app isn't able to perform its functions from beginning to end, like you would if you used Appium. There are lots of others out there. I shouldn't say lots. There are some others out there that you could turn to for mobile app testing. One of them has a popular project for doing functional testing of iOS apps. The downside there is that there isn't any repurposing of those functional tests to be performance tests. That's clearly one of Appvance's precepts or ideas. You should be able to repurpose a functional test to be a performance test. So with very limited support or no repurposing to performance tests, it means that you're going to have to write the functional test over again in the performance test environment just to move into performance testing. And that has a bunch of downsides to it. So let's look at what this looks like in terms of practice. So the idea of continuous DevOps is that you're integrating a continuous integration environment with an ability to do continuous deployment and continuous testing. So in one case, we might have a team that's working on data center switches. And it has a couple of engineers who are going to be, one's going to be an engineer or developer, the other is going to be a tester. They're able to define what the goals of their test are going to be in something called a test scenario. And they store that test scenario in their source code repository. That's either a copy of Subversion or Git. It could be CVS too. Then there's a controller, which is a piece of software that's going to get executed to execute the commands that have been defined in the test scenario. So let's say, for example, that the developer says, here's a software interface for a SOAP service, and I want the tester to test it. The tester can identify a test use case, which is going to know in what order to call the SOAP calls, and they're going to define that in the test scenario. The controller's job then is to stage the resources that are needed to actually execute the test in something I call a test node. For load runner users, this would be a test injector. And then the injector is going to make the requests of the app or drive the app itself directly. And so the scalability strategy here is that you could have multiple test nodes running concurrently to be able to run this functional test in parallel or to run this as a performance test. All of the results of the test node operation of that test are going to go into a results repository, which in this illustration says Oracle, but it could be MySQL or pretty much anything. The advantage of this kind of architecture for continuous DevOps is that you could easily have multiple teams operating within the same infrastructure. So the router team, for example, might also have a developer and a tester. They could be working on their own test scenario, also stored in Subversion or Git, and have their own controller in control of, say, 3 more test nodes. And what's really cool about this environment is that it plugs directly into the Jenkins environment. Instead of this being people, Jenkins can easily make a service call through the Jenkins plugin system into a test scenario, into a controller. So Jenkins is executing the build and deployment, and then this environment is going to do the testing. Pretty cool. So the way that you would configure Jenkins to do that, if this was an Appium test, would be to define for this controller how to actually start up the Appium server. So the controller would know how to start the Appium server, and then it would tell the test nodes, here's where that Appium test needs to execute, and Jenkins would be in control of all of that. Now, doing that can be kind of tricky. So on this slide, I've shown you a typical script that we would type into Jenkins to tell it to do 3 things, and I've labeled them A, B, and C here. So in A, we're basically starting up the Appium server. So you can see here we've defined like where the logging is going to be, what command to execute. This is going to be the Appium server command. What command to tell Appium to actually run, and then once the Appium server is up and running, then we go into B, which identifies like which Appium test script to execute, and then under C, we're waiting around for that Appium script to finish executing, and then to take down that server, take down the Appium server. So all of this is pretty easily automated. I mean, you can see that this is only basically, 20 lines of code. It's just not that difficult after you've done it 1 or 2 times in Jenkins. The thing is that there are easier ways of going, and one of those I wanted to show is here in the, oh wait, I'm sorry. One of the ways that I wanted to show you of this being easier is to take a look at any of the test automation platforms that are out there, including Appvance PerformanceCloud, which has all of this capability of Appium built into it already. So instead of having to do this within Jenkins, you can also use any of the Jenkins compatible software as a service providers to automate all of this for you without you having to like deal with these kind of scripts. Okay, so that was quite a bit already. I see we have about 25 minutes left, and so what I wanted to do is show you kind of some examples of using some of those technologies for creating scripts. And so first I'm going to show you how to do record and playback of an Ajax app. We'll be using the Appvance Designer, which supports the Sahi command language. And then I'm going to show you the same thing using SOAP UI to do SOAP and REST testing. And then I'll show you the Appium system for testing mobile apps. So the next couple of slides are all about like test script development. So here I'm going to go into the Appvance PerformanceCloud Designer. This has the Sahi proxy running If I tell it to start running a particular app, all I have to do is type in, say, the Ajax page's URL, and then choose which browser I want to record in. That Appvance PerformanceCloud proxy runs in Firefox, Chrome, Safari, Internet Explorer, basically all of the browsers. And then it can play back in all of the browsers too. I just have to select from here which browser I want to record in. So when I press the OK button, it's going to open its own instance of the Firefox browser. And you'll see that over here on the left. So let me just drag this over. So over here is the Firefox instance, and I'm going to tell it to start up one of my tutorial Ajax apps. We built this app using components from ext.js, which is a really popular Ajax component library. And so you can see that this app, even though it's in a browser, it has this kind of desktop app look and feel to it. Now, as I operate the app, it's going to be recording a test script for me. So all I have to do is click around to the various components within this app, and the designer in that proxy is going to record the steps that I'm taking to actually drive the actual end user experience. So I'm not doing protocol level testing here, I'm doing beginning to end testing. Notice also that I haven't had to type in any pause commands or wait commands. That's because the Appvance platform has enhanced this Ajax page with something called UX Avatar. It's a technology that understands whether each Ajax function is ready or has completed its task before you have to move on to the next one. So consequently, I don't need any pause or wait commands. So because I'm able to record and play back these tests so easily, I can also add like assertions, I can data drive these tests, and all of these tests are using this designer script language, which is basically the JavaScript language. So I don't need an expert mode, for example, to switch back and forth to. Like I would with QTP, for example. Okay, so the output of the designer is going to be basically a JavaScript file, which has some extra stuff to it. For example, data enablement for data driving this test, and that's going to be saved in a designer format. So that becomes very easy for me then to play back this script in the Jenkins and controller environment, either as a functional test or to repurpose it as a performance test. It's just that easy. Okay, so let's look at what the same kind of environment looks like for a mobile app. So this is the Appium environment running something called the Appium Inspector. It is the Appium record and playback tool. And what it does is it allows me to open up an iOS or an Android app. And you can see that over here on the right. And what I'm doing now is just typing on the keypad. And what you'll see is that Appium is keeping up by identifying the elements that I just typed into, where they are, and then all of the different commands that are possible for that particular element. And then here is like an XPath expression that allows me to get straight to that element. Now the cool thing is that once I've recorded the interaction of that iOS or Android app, Appium automatically gives me a Java object, which is a unit test of that app. So I haven't had to do anything more than just drive the app as an actual end user would, and here I am with an actual unit test that would then be easy to run from a Jenkins context to make sure that the app itself is functionally complete. And then using that integration from, say, Jenkins to the controller environment gives me the ability to repurpose this to be a loader performance test. Okay, so let me show you the third way of authoring these things. And this would be using the SOAP UI environment to create tests of SOAP or REST-based services. In this case, I can just type in, well, I'll just log in here, and then from the start page of the Appvance PerformanceCloud, I'm going to bring up our own version of the SOAP UI product. Just this time, it's going to be SOAP UI delivered as using a web interface. So all I have to do is click on that Service Suite link on the bottom here. There it is. And that will open up the Service Suite interface. Notice that this is a web-based version of the SOAP UI platform. I can create a new SOAP project by identifying the WSDL definition for that SOAP service. WSDL is like a definition language. It tells me which bindings are available, which services that I can call. For example, on the left here, you can see that there are two services, change price and confirm price. If I click on change price, it'll show me the XML of the SOAP request that needs to be sent over to the service, or I can click over here into a form view and just type in the parameters that that service needs to give me a response. Once I've typed it here, I just click on the play button or the run button, and what you'll see on the right is that panel will show me what the response is from the service. Pretty cool, huh? And I can do some fun things here, like use the data production libraries that Appvance provides to be able to take data from like a CSV file or a relational database query and plug that into the request or use that as an assertion for the response. Okay, so what I've shown you very quickly is three different ways to author your tests, either tests of an Ajax environment, tests of an iOS or Android environment, and tests of a SOAP or REST-based service. What I'd like to do next is to talk about why it's easy then to repurpose those functional tests that I've recorded to be performance tests. And I would ask the question in this way: why treat functional and performance tests differently? I mean, if you've already defined a functional test that can interoperate with an app, basically checking its function, why couldn't you just run that multiple times concurrently? Set up say a dozen virtual user threads on a controller somewhere and run those functional tests concurrently to one another. There's some clear benefits for doing this. First is that you'd have a single set of test scripts to do all of your testing. So you'd be able to do functional testing, performance testing, or stress testing all from the single test. What I find is that when you move into performance testing or stress testing, oftentimes you find functional problems. And so if you had a repurposing environment, you could very easily pivot back and forth rapidly. You could pivot from functional testing to performance testing. If you found some functional issues, you could pivot back into functional testing. And you could do this like instantly. It's also just a natural repurposing of functional tests to be performance tests is a natural for continuous integration and automation, because the combination of Jenkins with a continuous build environment like Puppet and a continuous testing environment like the Appvance PerformanceCloud, it gives you a natural continuous integration, a natural continuous DevOps environment for automation. So what I'd recommend you do is do performance testing and stress testing by basically running the test at 3 levels of virtual users. So you have your functional test already, run it at a low number of virtual users, like say 10. 10 virtual users running that functional test concurrently. Then step it up to like a medium level, like let's say 100 virtual users, and then step it up to say 1,000 virtual users. By doing that, you'd be able to see what the scalability index of the app under test looks like. In other words, how does the app vary its end user experience performance based on the number of users using it concurrently? So I call that a scalability index report, and it answers all of those business managers' questions about what's the risk to launching this app. So would you like to see this in play? Let's take a look. Okay, so the first thing to know is that the repurposing itself is done by defining something called a test scenario. And so for a functional test, I can go down here under use case and define the test itself by following an Agile method where I define the Agile use case for what I want to test. So I'm going to test an iPhone shopping cart. And then the first step of the test is going to be the first step within the test use case. So I could buy a product. And then you can see here a list of all the different supported script runners, and the Appium support is one of them. and then I can define what language I wrote or expressed that functional test in. So when I click on run or on play, this will run this as a functional test and it will run it once. But let's say I want to repurpose this to be a performance test. All I have to do is go up here to the test type panel and identify the different levels of virtual users I want to run concurrently. And then when I run this, it's going to actually execute the test at the 3 different levels, so at 100, 200, and 400 users. And then if you look over here at the controller interface as the test is running, it's going to show you the different levels of virtual users and what the actual throughput was from one level to the next. So in a perfect app, it would give me linear scalability, right? I'd be able to go from, say, 200 users to 400 users and see double the number of transactions executed. Look at what happens when this went up to the highest level of virtual users. Instead of executing up at this level, we were down here. So there was actually a performance bottleneck in this app that was surfaced by me just operating the app at these 3 different levels of load. Now, if I wanted to look in to see, well, what was really going on when this test was operating, I can take a look at the results analysis pages, and what this is going to show me is a correlation of the test transactions that were executed over the period of test time for this test, mapped to the CPU, the network, and the memory usage of the backend services that were supporting this app. So this is the kind of result work that you get by taking the effort of doing continuous DevOps. You marry Jenkins with a platform for defining the test cases like Sahi or JMeter or any of the others, with an ability to run these as both functional tests, performance tests, and stress tests. And then you wind up with a platform that provides your engineers with something that they can immediately act on, and your business managers with immediate answers on the business risk. Mira, were there any other questions at this point?
Yes, there are. I have 2 questions. I actually have 3 questions. The first question is, what backend servers does this correlation work with?
Well, the neat thing is that the Appvance platform comes with support for Windows Server, for Mac OS, for Linux, pretty much all of them. And it also integrates with other popular backend monitoring like New Relic and Dynatrace. So those come built in and integrated with this.
Our second question is, why not treat functional tests differently from performance tests?
Well, a lot of people will tell you that they have to be, like a functional test couldn't be a performance test. But I'd say most of those arguments kind of fall at the wayside when you realize that you could run a functional test concurrently with all of the other functional tests that you want in a set of virtual users, and that turns it into a performance test. You could think of a functional test as a performance test, but only being run by one virtual user. So in today's environment, where you could very easily run a controller in a cloud environment and then scale up to as many controllers as you want, as many test injectors as you want, there's no reason why you can't repurpose the same functional test to be a performance test or a stress test.
And our final question currently is, how many virtual users typically run on one of those test nodes?
Well, a lot depends on the app itself. Like if you're running an Ajax app that has its own database in the page, it might run slower than if you were running an app that was just making very simple use of Ajax and talking a lot to the backend servers. So we introduced this concept called calibration testing methodology. The idea is that you would run this test at, say, 3 levels of load and identify what the throughput is possible on those individual test nodes. And you do that by telling Appvance PerformanceCloud to do a calibration test, and all of that is automatic and very quick. In my experience, though, it's pretty easy with a dual-core, 2-core server to be able to get, like, between 10 and 20 copies of a browser running, with each copy having their own app and their own virtual user session. And those machines are like literally 15 cents an hour bought through any of the cloud providers. So the last test that we ran needed to achieve I'm sorry, the last test that we ran for PepsiCo needed to achieve somewhere over 1 million virtual user transactions within a 20-minute period of time, and we were able to execute that on 1,200 cloud machines. And those 1,200 machines came up for us instantly. If you want to know like how many virtual users are sized for your own private data center, like you want to do a comparison against, say, the cost of LoadRunner, then we have a whole kit for you, and all you have to do is contact sales@appvance.com for us to provide you that kit that would allow you to do that kind of calculation for yourself, and we'd be happy to assist you in that.
That's all the
Any
questions?
other questions?
Not at this time.
Okay, so we just have about 5 more minutes, and I wanted to cover a couple of other topics quickly or rapidly. So one of them is, we were talking just a moment ago about using the cloud to run a test of an Ajax app, and the challenge would be, what if you're testing a mobile app and you really needed to have good test coverage? So what I'd recommend you do is, instead of operating the test against just, say, a bunch of connected iPhone devices themselves, that it's okay to take a blended approach to mobile testing. So, for example, 90% of the tests themselves could run in emulators, like the Mac emulator. And Appvance has formed partnerships with cloud providers that have Mac environments to run these emulators. And then at the same time, you could run the test in real devices. Appvance has formed partnerships with companies that have like racks and racks of iPhones. And then at the same time, there are these really great platforms out there, like bug finders, which will contract out a test to be run by actual real people who are using their actual real devices, the real mobile phones. And those are available to operate at the same time that, say, Appvance is running a test for you in the emulators and real devices. So what you wind up with is a balance to the results, and even greater to operate these tests so that you can provide the business managers with business risk analysis. So, for example, you could say to your business manager, hey, we're going to run the test between 1 and 2 p.m. You get as many real people on it then at the same time that the continuous DevOps environment is driving artificial traffic to that app. Okay, so we only have a couple more minutes left, and I'm going to cover this topic for you, hopefully for your own kind of personal career growth. So what I would recommend you do is become kind of a continuous integration architect within your own shop, within your own office. Begin that by being that person who's standing there able to draw a line from business risk to an integration plan. So the integration plan might have things like a definition of the goals, what the test requirements are, what the continuous build and deployment and testing requirements are. And there's some pretty easy ways to get started here. The first might be, hey, if your organization is already pursuing an Agile methodology and they're doing those daily Scrum meetings, just sit in on them. You don't have to have an invitation to a Scrum meeting. You can just sit there and ask a few questions. Then after that, go and talk to the business manager responsible for the app about the business risks of launching the app. Ask the business manager, what kind of inputs do you need to do your risk analysis? I'd also ask the developers, have a conversation with them. Ask them something like, hey, where do you think the test coverage is thin? If they give you answers, or the business manager gives you answers, that's some stuff you can take back to the next Scrum meeting. But what would be even better for you as an individual within an organization is to choose a test script authoring tool, write or record a test, and commit that to the source code repository of your organization, and then plug it in yourself into the continuous integration environment and maintain it. You'd be surprised how much it will do for your own personal career and your own success within your organization. So the contents of that CI plan would be to identify the parts of the test, the parts of the integration, identify the success or fail criteria, understand what the user archetypes are, like the typical users of that app, and like what their typical workflow is. And then to be able to identify the kind of performance that you would expect to see the app under load and stress conditions. Now, these documents typically wind up being about, anywhere from like 8 to 10 pages long. If you want a template for this, all you have to do is ask us. If you need a continuous integration test plan template, just write to sales@appvance.com. We're happy to give it to you, and it's free. Okay, well, that's about it for today's workshop. What we covered today was the Agile methodology and how it expects kind of a build, deploy, and test automation environment. I think you'd be hard-pressed for reasons not to use continuous integration unless you're, for the reasons that I enumerated before. I think we've also presented for you a continuous integration strategy that accomplishes continuous DevOps, and I think that's kind of the holy grail for us right now. We've shown you Ajax and mobile testing methodology, and then also demonstrations of how there are both open source and commercial tools that make it really easy for you to author these tests. We also showed the concept in practice of repurposing a functional test to be a performance and a stress test. And then lastly, we talked about you becoming a continuous integration architect. So if any of this has spoken to you, if you're curious, how do you do this kind of integration work within your own environment, and you'd like to know more, please, we have a whole sales team that's ready and happy to answer your questions. Just give us a call at 855-254-1164 or email us at sales@appvance.com, and we will show you how.